Okay, I think we're ready to start. Thanks again for joining us. Welcome to this COLLARIS webinar. We're very glad that we can take this opportunity today to talk about UAS for detecting unexploded ordnance, UXO, a very interesting topic. And we are also very glad that we can be part of a conference taking place in Sweden today and tomorrow, the Drones for Emergency Response and Civil Defense Conference. And we're also very happy that we have 3 speakers today in total. The first speaker today will be Anna Kobiaszicka. She is from Poland and she's the COLLARIS project coordinator. And she will, as the first one on the agenda today, talk about our project, about the COLLARIS network, what we are aiming to do. Then we have a second speaker, who is Jonas Fröjmark from the Swedish Competence Center of Unmanned Vehicles. He's an incident commander, also at the Södertörn Fire Department Association. I'm hoping I'm saying this right. And then we are also very happy to be joined by Dietmar Letalik from the Swedish Defense Research Agency, FOI. And yeah, I think that's all I have to say for now. No, actually, I should introduce myself as well. My name is Johanna Zweiger. I'm with DCNA, Disaster Competence Network Austria. We are one of the partners in the COLLARIS project. And yeah, I'm responsible for all things communication, so to speak. Speaking of communication, in case you have any questions, we are happy to do a short Q&A session afterwards, after the 3 talks. So please, if you do have any questions online, all of you taking part online, please do write them down in the chat. And if there are any questions at the conference in Skövde, our colleague Ulf will be happy to organize that you can actually ask these questions in person as well. So yeah, I think that's it for now. And over to you, Anna, for the first talk about the COLLARIS network.
Thank you very much, Johanna, for this excellent introduction. And let me start by thanking the organizers of the conference in Sweden. It's great that we could join you in this hybrid event. It's not really a webinar, it's a hybrid event. And I'll be glad to give you a very brief introduction on about COLLARIS network, who we are, what we are doing, and what we are still planning to do. And then we will move on to the actual topic of the webinar, so the UAS for detecting unexploded ordnance. So COLLARIS project, who we are and what we are doing. So our general objective is to stimulate a wider and more complex use of drones in crisis management and civil protection. The basic assumption is that technologies are there, drones are there, but they have much more to offer than it's actually used. What is lacking, as I said, it's not the technology itself, but it's the soft aspects. So we need to share our practical experiences and lessons learned from the use of drones, how to cooperate, how to share the data obtained by the drones, how to coordinate multiple drones flying over the same crisis area and possibly also share the same airspace with the manned aviation. So those are the challenges that we're trying to address in the COLLARIS network. So how do we do that? By organizing events like this one, but also thematic workshops and physical and online conferences. We carry out some small research activities, studies, and analyses, like, for instance, the foresight report that we prepared 2 years ago about Horizon 2030 Horizon for drones in civil protection and crisis management activities. We are working on trainings and virtual simulations. But not only that, we also carry out physical field trials to verify and validate our theoretical findings from the previous activities. And last but not least, we do our best to support both individual and institutional capacity building by any means we have. What those means are, well, the observatory of best practices. So we try to analyze the most common scenarios of the use of drones, like, for instance, wildfires, floods, drones coming as the first responders before the actual human team arrive on place. Autonomous operations, so drone in a box, basically. Mapping. This is the critical advantage offered by the drone. We can see what's actually happening. And last but not least, air traffic management aspects. So as I said, if we have multiple drones flying over the same area, we have to make sure that they are able to fly safely and in a coordinated manner. We have various activities for support for uptake of lessons learned. And here I would like to underline the first one. We are conducting an overview and selection of interesting drone use cases. And actually today's webinar is one of those use cases that we want to share. But I encourage you to visit our website, because this is just a part of the whole series of different drone use cases. For instance, we have a drone use case for triggering controlled avalanches in the Alps, or using drones to get water samples from remote areas. So this is a part of the ongoing series of short publications and studies that we are conducting. We are also involved in preparing trainings and virtual simulations. And last but not least, data analysis and data sharing to improve situational awareness. So those are the main lines of activities that we are pursuing under COLLARIS2. Who we are and who we want to be in the future. We are a network of stakeholders from various organizations interested in the use of UAS for crisis management, first response, and related applications. But our ambition is to become a kind of a distributed knowledge center focused on the use of drones in civil protection. And I hope we are on our way to become that. And we want to offer to everyone interested a platform for discussion and exchange of knowledge about future of drones in crisis management. A bit about what is still going to happen in the COLLARIS2 this year, and I would like to cordially, of course, invite you to take part in those activities. Just if you are interested and want to learn more, drop us an email and we'll be happy to include you. There will be a trial organized in Sweden, in Stockholm actually, in mid-June. It will be focused on the virtual simulation and training, and it will be synchronized with the final demonstration of the Synergize project. There will be another trial more focused on air traffic management in Poland in September, and two smaller scale trials in the Netherlands and Cyprus. The interesting drone use cases I have already mentioned, air traffic management as well. You can visit our website if you are interested in the structured overview of national drone regulations. It will be published soon. And we are now carrying out an analysis of the use of drones in volunteer and professional organizations. And we have recently published a study by DCNA actually about the public perception of drones in crisis management activities. What is the general population attitude towards drones and in this particular crisis management scenario? So this is who we are now. You can see the map with the consortium, core consortium partners and associated partners. And if you want to become a dot on this map, we'll be glad to have you. We want to continue our activities. We want to try and apply for COLLARIS-3. So again, if you want to join us, we'll be glad to have you. And with that, I will give the floor back to Johanna to carry on with the webinar and the other speakers. Thank you.
Thank you, Anna, for this introduction to our network. So also from my side, yeah, you're very welcome to follow the COLLARIS network on LinkedIn, for instance, where we post regular updates. And some of you might have even seen the webinar there on our postings. That's the first point on the agenda today. Everyone who joined in the meantime online, welcome to you as well. Like I said in my introduction, the webinar is part of a conference in Skövde in Sweden, Drones for Emergency Response and Civil Defense, and that's also where our next speaker, Jonas Freumark, is at the moment. He is an incident commander at the Södertörn Fire Department Association and also representing the Swedish Competence Center of Unmanned Vehicles. And he will be talking about recent tests that were conducted in Sweden in terms of UXO. And with that, Jonas, I invite you to start your talk and also show us your slides, please. Thank you very much.
Thank you. I hope you can hear me. And thank you for the nice introduction, Johanna. Like you said, I'll be talking a bit about some field tests that we have been doing in Sweden, relating the use of UAS for detecting unexploded ammunition and rockets and so on. A brief introduction of myself. Like you said, incident commander in Södertörn. It's a municipal fire and rescue federation in the southern part of Stockholm. You can see it on the map there. We do have an US organization at our fire department consisting of pilots that we train from the firefighting squad. So we take a pilot from the firefighting squad when we got a call. And we fly mostly with the Matrice 4TD. This is our main platform, and this is also the platform that we used to do this, the testing with the unexploded ammunition. So briefly, this was our focus areas when we started these testings some 9 months ago up in Kiruna in Sweden, where we had the opportunity to do a large-scale test together with the MCF, the Ministry of Civil Defense in Sweden. So we wanted to know, also based on the information and the lessons that we learned from our Ukraine colleagues, how we could use the drones in assisting our personnel to do a safer and more efficient work with in a high-risk environment. And the hypothesis that we have, and also what we have learned from Ukraine, is that we actually can use the drones and that they are of great benefits for us. We can do the identification and marking of the UXO, and we can also do a simple triage from the air to see how many victims we have to work with and where those victims are. What we haven't been doing yet, but what we are going to look into in the near future, I hope, is to also equip the drones with sensors to be able to detect CBR and threats to us. And we will also continue to monitoring what is happening in Ukraine, of course. The lessons that they have learned there comes with great costs, and we really appreciate that the Ukraine colleagues have been very, very generous with sharing information with us. So I think it's our responsibility to take those lessons to heart and really work with it. So we're really happy and grateful for that. So, and the kind of goal of all of this is to develop a basic methodology, basically, so we can learn how to operate in these kind of environments. Like I said, we were in Kiruna this last autumn, and we had prepared a test site that would simulate a strike with a ballistic missile on a residential building. And we tried to look as much authentic as possible, with a lot of debris around and a lot of people injured. And we put the personnel in this kind of environment, and this was kind of the start to see what can we use the drones to aid the personnel and how we will develop from here. And we started, and we kind of saw that it's not very easy to find these threats among this kind of debris, to find where are those unexploded grenades, and if we have warheads or mines or anything. There's a lot of things to look at a scene like this. So we need to develop a search method to work with this in a more elaborate way. We don't have it as of today, but we are working on it. And like some of you that participate in the conference here in Skövde heard, we are going to do more tests in Kiruna at the same site later this year. So we take what we learned from the first testing and kind of develop it and twist it to make it even better the next time. Like I said, you can also use the drone, of course, to identify where you have the victims. And therefore, you can also be more precise where you want to put in your personnel. Perhaps if we have people that cannot be saved, then we don't have to put our personnel at risk to go in those places. But here we have somebody that we could save. Okay, let's focus there. And what kind of threats do we meet on our way to these victims? And all of these pictures that you're seeing are being taken from the drones. And we kind of, like I said, this was the first test, so we didn't have any kind of methodology in place. It was kind of trial and error, but we even at this point we saw great potential. And afterwards, we did testings in Skövde last week, kind of on the same theme, but more elaborate. And at those tests, we also wanted to try what can our normal pilots in the fire brigade do with our normal systems that we already use. Here you can, by the way, see a small grenade up on a roof that we found with a drone. That would have been impossible to see from the ground. Also, you can, like I said, you can search the areas, but to do it efficiently, you have to have those methodologies in place that we didn't have back then when we did these trials. But what we saw in Skövde last week was that actually our normal pilots with not very much training, they can already at this point be of great use for the incident personnel. They can be guided by the drones. They can pinpoint where the victims are, and the potential for further bringing this up to speed is very great. But we do have some work to do. Also, we did some indoor flights, and we have. In Sweden today, we have not, of course, the same extreme situation that you have in Ukraine, but we do have some criminal gangs that like to put explosives in residential buildings. So it might look a bit like this, and these techniques might be very useful even at those cases. And the dual use part is of big importance, I would say, because if we learn to use drones in a way that can help us work in a more safer way, even when we have explosive threats around us, then we can use it in our day-to-day business as well. Then we will be able to use it if, hopefully never, but if we would get attacked by an enemy as well. So basically, the results are that we already have seen a great potential for working in a safer way for our personnel, and also a great time-saving potential. I will not say that we have realized all of that potential as of today, but we still need to work with this to find those methods and to find standard operations procedures, so to kind of streamline this work. But the potential is there for sure. We also have the need to have a better system for sharing the data that you get from the drones with the ground personnel. We don't have in Sweden as of today a good system for that. We learned from our colleagues from Ukraine that you do actually have systems in place, and I know the Swedish military have some systems as well. The fire brigades in Sweden are divided in municipal areas. So each and every fire brigade, there's like 130 fire brigades in Sweden, I think, 140 perhaps, something like that. Each and every fire brigade has to kind of invent their own system. And that's not a very productive way to work. So as kind of a way to make that better, we also have this recently started the competence center that I will work with. It just started a few weeks ago. So one of the focus areas of this center is also, of course, the kind of bringing the Swedish firefighter organizations together and to see if we can find a better way of working, not only with wartime scenarios, but also our daily day-to-day scenarios. And I will stop there. And you have my contact information. I think that if you scan the QR code, you will get an email to me. So if you have further questions, or if you want to reach out to the competence center that we are starting up in Sweden regarding not only drones, but also other kinds of unmanned vehicles, you are welcome to contact me. And also if you have any suggestion of what you would like us to do in the future. We also see, of course, the big potential of working together with COLLARIS, since it's kind of the competence center in Sweden will be kind of a small version of COLLARIS, but for Swedish rescue services. But to be able to gain the information that you gather from across Europe, and also perhaps bring our use cases and put through COLLARIS back to Europe, I think it's there's a big potential that we actually could learn from each other instead of everybody on their own trying to invent the wheel. Thank you for your attention.
Yes, thank you, Jonas. Thank you very much for your insights. You mentioned the questions, so again, also addressing the participants online. If you do have any questions, feel free to put them in the chat, and we'll try to answer them after the next talk, which will be by Dietmar Letalik. He is with the Swedish Defence Research Agency, FOI. He's actually joined the FOI quite a while ago in 1981. And he has researched electro-optical sensors there for various military applications. And he has also been a project manager for several projects on the detection of mines and IEDs. We'll hear about that in a moment. He'll be covering past and present work at the FOI in his presentation today. So Dietmar, thank you again for joining us today. The floor is yours, and please do share your slides with us.
Thank you, Johanna, for the nice introduction, and thank you very much for the invitation to give a presentation at this webinar. Just to check, can you see my PowerPoint?
Yes, thank you.
Okay, yes, I'm with the Swedish Defence Research Agency, located in Linköping, Sweden. Here we do research mainly on electromagnetic sensors, but I would also like to mention a division in Umeå in the northern part of Sweden. They do a lot of work on protection against the CBRN, and they are also involved in putting that kind of sensors on UAS. My presentation today will cover FOI activities in my division, and at the end I will also mention a few words, or say a few words about some ongoing EDF and EDA projects. At FOI we are quite involved in using UAVs and UAS mainly as platforms for sensors. So we have something like 70 pilots today. So and that number is growing. So we have quite some experience with using drones. Just a little bit of background. The way we have used the sensors for these purposes that is of interest today is to detect regions that differ from the surroundings. That is to do anomaly detection of various kinds, and we've been involved in this kind of research for more than 20 years, mostly for military applications. Many years ago we did some development on handheld ground penetrating radar, GPR, for the detection of landmines. Then the world changed, or the threat, so it was of very important or large interest for the Swedish Armed Forces to detect IEDs, improvised explosive devices, and also landmines. So in those days we worked a lot with various kinds of electro-optical sensors from the visual range, visual cameras, and all the way through up to long-wave infrared thermal cameras. We also did research on hyperspectral imaging and polarimetric imaging to investigate different physical aspects of these kind of cameras and how they could do in the search and detection of mainly of IEDs. We have also been involved in using 3D LiDAR for detecting surface-laid objects, for instance, to use LiDAR for change detection to see if something has changed in the scenario along a route, for instance, to look for roadside IEDs and so on. So we haven't been looking very much into detection of UXOs or finding UXOs, and I'm a bit humble in this aspect. To find UXOs in urban areas, that's a extremely difficult environment with a lot of clutter, a lot of false positives, a lot of metal and debris. So it is really a tough job. In particular, if you also want to detect buried or objects that are below ground, that have been covered by ground or debris. So that is something to bear in mind. Cameras, electro-optical cameras, can be of good use if the objects are on the surface, as we heard in the previous presentation. A bit of a history. We participated in a EU FP7 project back in 2016. And this is an example of the results that we got there. The project was about humanitarian clearing of large areas from anti-personnel landmines. And we were at a test site with some kind of sand pit looking like this, and there were number of anti-personnel mines, surrogate mines buried in the sand. And this is in the large picture below. You can see the result from a thermal camera, long wave infrared, where you can see the dark spots here. The AP mines were buried a few centimeters below the surface, so they were not visible on the surface. And we did recordings of the diurnal variations. That is, we recorded the image for like 24 hours to see how the scenario changed, and depending on the different thermal properties of the buried object and the surrounding sand. In this case, you can at least sometimes during the diurnal cycle see a large contrast between the buried objects and the surrounding ground. An example of hyperspectral imaging. This is a slightly more recent example where we used deep learning to search for areas that does not correspond to background. And in this image, we have some objects, side attack mines that show up in this processed image, a bit highlighted. You can see them here. So this is an example of how we can use AI to improve or to process the data. To a present project then that is ongoing now at FOI is to put this kind of sensors that can be used on UAVs. So what we basically have done is to use commercially more or less handheld sensors and to investigate how they can do and be used when we put them on a UAV. So we have investigated a number of different types of sensors, sensor modalities like a magnetometer, ground penetrating radar, metal detector, nonlinear junction detector, and a command wire detector. And the reason, of course, for investigating the use of these kind of sensors on a UAV is to increase the safety for the operator to get standoff distance, and also hopefully to increase the search capability and the speed of search over a larger area. Just an example of the results from a ground penetrating radar. We put GPR from the Swedish company radar team, mounted it below a UAS, UAV. Size and weight of this GPR makes it well suited for mounting on a small UAV. Some technical details that we perhaps don't need to look into too much, but the results, as some of you may be acquainted with GPRs, is that it is quite a complicated matter because a lot of parameters change. The ground coupling, you need to get the signal into the ground and get a return from the buried objects. There is a ground return that might complicate the signal processing. Differences in the conductivity in the ground might make it more or less difficult to get a good signature. Did we lose the image or can you still see my presentation? Something happened on my screen here.
I can still see it.
You can still, okay, yes.
How about the conference participants?
Yeah, I think now I got it back here.
Okay.
So
yes, it's okay.
Perfect.
Yes.
Yep, thank you.
Below right here, this is an example of some buried objects. We buried some anti-tank mines, some other types of objects, piece of plastic, and a sewer pipe and a plastic rod. So you need to be a bit experienced to interpret diagrams like this. but nevertheless you can see if it is working well, you can see a couple of decimeters below ground and the detect buried objects. Of course, there might also be a lot of false positives from other objects apart from UXO or mines and so on. So it is not completely straightforward. Another type of sensor is an NLJD, as we call it, nonlinear junction detector. And what that type of sensor does, it's basically, it senses the presence of electronic devices. And the devices don't need to be powered up, but electronics. So we put a COTS handheld sensor. The sensor head is here. We put that on our drone, and we put the antenna a few meters below the drone, and so this way we could fly over an area and get detections from electronic devices that might be used for triggering an IED, for instance. So all objects that continue some kind of electronics could in principle be detected by this device. We've also been working with a magnetometer. This is current work at FOI at present to build a custom-built magnetometer made up of an array of small, fairly cheap components. And this boom that is about 2 meters long will be mounted below our UAV, and we will hopefully after summer conduct some trials with this magnetometer. To start with a hand, putting it and just walking handheld, but then also mount it on a UAV. We have also investigated putting a conventional metal detector on a UAV. This was not that successful because we found out that it was very sensitive to electromagnetic interference from the UAV, from the rotors. But in principle, this technology, the sensor, is a good one to find pieces of metal. So we have a current work going on to develop a UAV with less noise, and probably to put the sensor a bit below the UAV also to decrease the interference from the rotors. We have no results from this yet to present. A few words about some international projects. At present, there is a project, a challenge financed by the European Defence Fund, and it is called Unmanned Ground and Aerial Systems for Hidden Threat Detection. So this could, of course, also be UXO. It's a 4-year project, and we are in the middle of it right now. So it is a challenge, as I said. So what FOI is doing, we are coordinating one of 5 projects here. It's called HitDoc, and the task for HitDoc is to organize a technological challenge. The challenge is about 4 annual tests at the test range, and there are 4 participating projects in this challenge: ADDX, Convoy, Determine, and Tike. And these participating projects, it's quite a large number of participants there, or partners, like 40 partners in all. And the 4 projects come to the test site that is organized by HitDoc, where we have a scenario with some threat objects, both on the surface and buried objects. But this is all only military objects. And as I said, we have now so far conducted 2 challenges, and the next is in September at the FOI test site south of Stockholm. So we have two more tests to do before this project ends. And there is also another project that we at FOI are participating in. It's called IDDET2. That is an EDA project, and it is coordinated by TNO in the Netherlands. And this project is focused on multi-sensor systems and sensor fusion. So pictured here in this diagram are quite a number of different platforms, a number of UAVs for different purposes, and also ground UGVs, and with different sensors. And all the detections and the information from the sensors go into a sensor fusion process. And of course, same purpose here is to use unmanned platforms to increase the standoff distance and increase operational safety. And I think we are using almost all types of sensor modalities that can be used for finding IDs and mines here on the different platforms. Recently, just a few weeks ago, we did a first test in Austria, and the final test and demonstration will be conducted in April next year, and the project will end in June next year. So, in summary, detection of UXO is a very difficult task. There is no silver bullet, a single sensor or a single platform that can do the job, but you can for sure get some help or assistance to the human eye with different kind of sensors. And at FOI, we are investigating various kinds of sensors put on UAVs that can be used for this purpose. So no silver bullet, as I said, but what you actually need is a toolbox of different sensors and platforms in addition to the human eye, which is quite a good sensor for this tasks also. But with the sensor and the remotely controlled vehicle, UAV, of course, you get the standoff distance, which is very important in rescue operations in dangerous areas. So by that, I leave the floor open to any questions. Thank you.
Thank you very much, Dietmar, for your very interesting talk. I don't see any questions yet in the webinar Q&A, but I have one myself, if I may. You explained, both of you, Jonas and yourself, Dietmar, you explained what's been done before, what's possible at the moment. Do you have a vision of what might be possible in the future when it comes to detecting UXO, and maybe some things you would be hoping for that will be possible, let's say, in a few years? From a technical standpoint, is what I mean.
Yes, I mentioned the magnetometer that we are working on currently, and I hope that could be a good type of sensor to be used. Then I'm not sure that there are any good solutions. Of course, smaller, lighter sensors that could be put on small UAVs, that is something that we could foresee in the future. Of course, AI support when it comes to, at least when it comes to visual sensors, cameras, RGB and infrared cameras. I think that AI could be a very good support to the pilot or the operator that looks at the image.
Jonas, if you can still hear us, hopefully, do you have something to add to that? Maybe some things that you maybe wish will be possible in a few years.
And yes, I can only add to that we for sure hope that AI is going to help us a bit to interpret the images that we are receiving from our sensors. From my point of view, looking at the picture at the last presentations, the radar images and so on, it's not very likely that we in the fire and rescue services will be able to use those kind of sensors and to interpret that kind of data. Then for sure we would need help of either experts or perhaps machine learning systems that can help us get the information that we need from the data.
Yeah, I can add that to the ground penetrating radar. Of course, the diagram that I showed is not very easy to interpret for an operator, but we using some post-processing that we have developed, you can get the location on a sort of a top view map of objects of interest. So that is what we are working on and what you can get.
I also think sorry, yeah, but if we're trying to look into the future, that we will see more and more autonomous systems that will help us. That so that you take away some of the pressure from the operator. You don't have somebody perhaps flying the drone like this, or flying or driving the UGV, but you have autonomous systems for that, and also perhaps speed up all of these processes, because we do work in a very time critical environment, so we need it to be fast and easy to deploy. And I hope that tomorrow's technology will help us with that, to be faster and more efficient.
Thank you. I think we have a question from Anna, who also put it in the chat, so I'll ask it myself. So yeah, you talked about the positive developments and your wishes, but what about any obstacles or problems that you might be facing? Maybe you can share a bit about that.
Yeah, I can start. I don't have any experience from this kind of areas, or to find UXOs. We have mostly been working with minefields and roadside bombs, which I mean the environment is somewhat easier. I'm thinking of all the debris that is on such a site that you might come into as a rescue service. And many objects, threat objects or UXOs, is probably buried, and that is a very difficult task to find them. If they are on the surface, yes, you have a good chance of finding them using sensors and AI. And of course, not only the objects themselves, but there are a lot of clutter, reinforcement bars in the concrete and so on. So it's an extremely difficult environment to search for UXOs, I imagine.
Jonas, do you want to share about any possible obstacles or problems?
Well, for the fire brigades in Sweden, anyway, there's always the question about finance. To get the money to buy this kind of equipment. It's not very cheap things to buy. We don't usually have the budget for it, and therefore it's also difficult to be able to test things when you don't have the possibility to buy them. So we need help from other parts, from the universities, from the industry, and on the state level perhaps also. So we actually can be able to find out for ourselves what would be usable for us in the fire brigades.
All right, thank you. We have another question in the chat from Manolis, our colleague from Greece. He's saying, do you see multi-sensor, multi-purpose potential solutions on a single UAV or autonomous single sensor solutions? Maybe you can touch on that a bit.
I think it's a question about the weight of the sensor, size and weight of the sensors. If we have small sensors, we can put multi-sensor, have a multi-sensor solution on a single platform. For sure, I think that multi-sensors and sensor fusion is part of the solution. So if the sensors are too heavy to put multiple sensors on a single platform, then multiple UAVs or in combination with UGVs on ground vehicles, perhaps I think that could be a way forward.
Comment from you, Jonas, maybe as well?
We do have questions from the audience here in Skövde. So I will give the word to Dimitri here.
Perfect, thank you.
Hello, my name is Dmitro. I'm from State Emergency Service of Ukraine. I have a little comment, maybe question. In Ukraine, we have a few systems with magnetometers, with some sensors, etc. And we tested a lot of these systems, and I saw these systems since 2022. So I can say we don't find a silver bullet. Yeah. I just want to comment because of all of researcher looking for a silver bullet for the mining, for detecting. Actually, I should say all what we tested and it works in laboratory conditions doesn't work in real conditions, because of in real conditions you have a lot of metal, a lot of trees, grass. You don't have ideal conditions, so it works. All of these sensors not effective in detecting. So in Ukraine, I heard many times from our demining units they don't trust in this technology still. Actually, it's just a comment from us. Now we are looking for new solutions. Maybe in the future we can do something in this sphere. But detection is a really, really hard task and very difficult to find something with UAV. It's just a comment from me. Thank you.
I totally agree with that comment.
One comment. The Denmark has a most interesting system. It calls a V2MAG. Yeah, maybe you should try to talk with them. Yeah, it's a most interesting system. What I see, what I saw. Yeah, this is magnetometers. Yeah, thank you.
Thank you. Are there any more comments or questions, both online or at the conference in Sweden?
No more questions from Sweden at this moment.
Okay, I don't think we have any more comments or questions in online. So that's it, I suppose. Thank you all once again for joining us today. If you are interested in this topic, UAS in disaster management in general, be sure to follow the COLLARIS network on LinkedIn, as I said before. Yeah, I hope you'll have a very interesting conference day tomorrow as well in Skövde. And yeah, thank you very much and have a nice evening and goodbye.
Thank you very much.